Hello. So hello everyone, and in this video we'll be learning about priority queue data structure. So in the previous videos we have learned about stack queue and circular queue. Now we are learning about priority queue data structure. So how is it different from a normal queue? We'll understand that, and what's the benefit of using a priority queue? What are the situations when we'll actually need priority queue? Okay, so as the name suggests, it will actually dequeue that element which is in priority. That means if I say that you are standing in a line of 10 people, and you would say that suppose if someone in middle, uh, suppose if I talk about hospitals, okay, so there might be different kind of patients with different problems. But suppose somebody is about to die and they are actually too late, like they just came right now and 10 people are ahead of them. So what must happen is that the person who is about to die or something must happen, they can actually forward themselves. That means they are prioritized, they can actually go forward. So it actually means that the process or anything which is in priority must be done first, right? If you are standing in a line of 10 people, the person who needs the thing the most will get the priority. Okay, if that person is a VIP, they will get a priority. It's like that. So that what priority queue is. So let's follow the explanation first. We'll be starting with the definition. Okay, so a priority queue is an abstract data type that stores elements along with their associated properties, priorities. So I would say that this is element A, it has a priority 99. This is element B, this has priority 95. This is element C, this has priority 1. So what would happen is, if I talk about ascending order, I would say that the element with least priority value will be actually taken first. That means if I talk about the order which I mentioned right now, C will be removed first, then B will be removed, then A will be removed. Okay, similarly you can use it for descending order. You would say that if you build a different kind of priority queue function or logic, you can also say that the element with most priority value can be removed first, or element with the least priority value can be removed first. Okay, it's like that. So priority queues have various applications, including job scheduling, prioritizing tasks or jobs based on the urgency or importance. Like suppose you are working on your computer and suddenly some important job comes. So actually all the processes are stopped and that important job will be completed first. It's like that. Okay, and the second example is path finding algorithms. So to find the shortest path in a traversal, in a graph traversal, you can actually use the priority queue. Like it's actually used in Dijkstra's algorithm or A star search algorithm, which you can learn in the algorithm part. Okay, so now one more usage of it is data compression. So actually the Huffman coding uses the priority queues to assign shorter codes with more frequently occurring elements. Okay, so event driven simulations are also using the priority queues. In this we actually handle events based on their priority or schedule time. So this is a very basic overview of how priority queue is used and what is actually priority queue. But now what we'll do is we'll draw it on our whiteboard so that we get a better idea out of it. So before continuing, in the live chat or in the description you find a course provided by Geeks4Geeks, so you can check out that course. It's actually for DSA in JavaScript. Okay, so it's a paid course. If you want to purchase it, then you can buy this one. And in the description, you'll find a lot of details here. And also in the course content, you can see that everything is teached from the basics, which is required not just for JavaScript, any language. If I talk about, if you are trying to learn DSA in some other language, you'll still find the same content. Okay, so this content is very valuable, and if you want to learn DSA properly, not just JavaScript, any language, you can follow this course. Like right now, if you try to learn this in JavaScript, DS in JavaScript, you can later on switch on very easily, because JavaScript is still a very great language, and you can use it for DSA very well. And if you are building some complex backend, or if you are into web development, you would always need DSA also for some advanced logics. Okay, so yeah, do check out. So now we can continue. So I'll just open whiteboard here. Let's wait, it's taking time, I think. Fine. So now you can see that it's done, and what I'll do is right now we'll be drawing a basic queue. Okay, so I'll just format it and let's make it this. Okay, fine. So what I'll do is I'll just draw a queue here very fast. Okay, so suppose this is actually a queue, and you can also assume it as an array. Okay, you can assume it as an array. So you can see that right now, suppose it has some values like A, B, C, D, E. You can assume all these as some processes, right? So as some processes, you can assume these, and the user actually enqueued this process in this order. That means first A was added, then B was added, then C was added, then D was added, then E was added. But the problem is, suppose if D needs to be completed first, D is a process which is very important and needs to be completed first. How can you do that? So for that, priority queue was introduced. So the usage of priority queue is very easy. Whenever you are adding an element, whenever you are enqueuing an element, along with it, you will always add its priority. Okay, suppose if I add its priority with suppose 3, and I'll say that this is having some priority of 2, and this is having priority of 1, this is having a priority number of 5, this is having priority number of 4. Okay, so what actually happens is, whenever you are adding things in a priority queue, what happens is you actually prioritize things in that order. That means, suppose initially, if I talk about what actually happened here is, in priority queue, things are not added in the direct order which are they mentioned. It's not like that. If you first of all, suppose if your queue is empty, obviously A will be added. Okay, A will be added to the queue. Okay, but next what would happen is, the priority of A was 3, but next what would happen is you are adding B, and you can see that B has priority 2. So right now I'm considering the element which has less priority, less value, less priority value equals VIP, or you can say priority. Okay, so you can say that before A, actually B will be added. That means things will be shifted in this way. We'll be actually using the splice operation which is available in JavaScript. So what would happen is, now B is actually available before A. So B is actually a high priority process. Now after this, you can see that C came here. Okay, so before B, actually C is here, and later on the elements are pushed forward. Okay, so again the splice will be performed. Now D came here. Okay, so D came here, so you can simply write D here because D is having a bigger priority value, so you can do it later. Okay, so D is here. Now after this, E is here. So what would happen is, you'll shift D a bit. Okay, you'll shift D a bit, and what you would do is, actually you would pass E in between. Okay, so D would be actually shifted and you would pass E here. Okay, it's like that. So what we'll do is, we'll shift the values to their expected position, and then we insert the less priority number value. Okay, less priority number value means that it must be covered first, it must be dequeued first. It's like that. Okay, so now in this case, if I talk about dequeue operation, enqueuing works this way: A, B, C, D, you enqueued in this order. Okay, but actually things are stored in this order. Okay, things are stored in this order, not this order, not this order. Things are stored in this order according to their priority values. Now what would happen is, if I want to perform DQ, DQ will start from the first element, then the second, then the third. It's like that. Okay, so first of all, you are actually sorting things up in this order, in any order. It's not like you have to sort it in order 1, 2, 3, 4, 5, not in this order. Okay, you can actually sort it in this order also: 5, 4, 3, to 1. That means the value with highest priority can be dequeued first, or in this case the value with lowest priority value can be removed first. Okay, it's like that. So both case can work, but right now today we will be actually following this ascending one. Okay, this ascending one, we'll be following this ascending one, ascending priority queue. Okay, so we have a doubt here. Same code for TypeScript or any change should be there? No, there shouldn't be any change. Yeah, obviously you can mention the types like we'll be using numbers or strings, so that for that. But yeah, you can mention the type as any, it will work. Okay. All right. So now what must happen is, now what we'll do is I'll just write the code implementation for that. So for that you can assume that we are actually going to give an input. Okay, so we'll write the input here. So how are we going to input? Okay, so I would say that first of all that I would say that the value is a and its priority is suppose 5. Priority is suppose 5. Then I would say that let's draw a priority queue here. Oh, somebody said hi on the live chat. Hello bro, how are you? So yeah, here you can see that right now this is our priority queue. Okay, and initially you can see since we have added a, so what we'll say is we'll just pass a as it is, pass a as it is. Now next time what would happen is I would pass some other element like b. Okay, suppose the b is having some priority of 3. Okay, b is having priority of 3. So what would happen is we'll simply I'll just draw some blocks so that we can have a better idea. So right now you can see that second, third. Okay, fine. So now you can see that B came here. So what would happen is we'll simply shift A to the second position, and we'll simply add B here. Okay, and simply after this you can say that suppose a next element came here, and I would say that its value is 1. Okay, so what would actually happen here is now this value will be shifted again. C is having the least priority value, so it will be actually, you would say that it will be dequeued first. Whatever value is here will be dequeued first. Okay, whenever we'll perform a dequeue operation, this value will be dequeued first. Whatever value is at the 0th index, right? We assume that. Okay, 0th index, first index, second index, third index, fourth index. Okay, indexing is just for reference. So now you can see that yeah, b must be here and a must be here. Okay, so now suppose some other element came up here, and I would say that d is actually having some priority of 2. Suppose 2 is here. So what we will check is we'll start from the 0th index. We'll check that is this C having bigger priority than D or not. It does not have bigger priority than D. So we'll check for the next element. So we'll say that is this B having bigger priority than D. So you can see, yeah, B is 3, B is having priority 3 and D is having priority 2. So what would actually happen is we'll again perform a shift operation here. Okay, shift operation here. Okay, so that's how we'll actually do things. Okay, so for better we'll be using the splice operation available in JavaScript. So yeah, it's D B A. All right, so that's how things will work. Again, what I would say is let's start with the next value, and suppose if I give again an input like we will give E as input, and now I would say that yeah, suppose this priority is 2. So now what would happen is we'll check for the first element. We'll check that this C is having greater priority than E or not. No, C is having priority 1, so it won't be changed. Again, we'll look for D. D is having priority 1. Okay, D is having priority 2, and E has priority 4, so we'll again don't do anything. Again we'll go to B, we'll check that B is priority having 3, okay, and E has priority 4. Again we don't do anything. But now here you can simply say that A has priority 5, E has priority 4. So what would happen is since this is greater, we'll simply shift A next, okay, and then what would happen is we'll simply pass E here, okay, we'll simply pass E here. All right, so now I have a homework for you. Suppose we have a value named as F, which has priority value 2.5. Just tell me how things will work. Okay, suppose we have some extra space here, how things would work. Okay, just draw a diagram and let me know that you can take it as a homework and you can understand yourself, and then you can just let me know that what is the order for that, C, D, B, something like that. You can just let me know the order for that. Okay, so where will F be inserted exactly? Alright, so this is a very basic explanation. Now we'll be using the same logic for writing the code. Okay, then what would happen is we are actually performing the NQ operation here. Till now we were performing the NQ operation. We were adding things and we were sorting things like that. Okay, somewhat we are sorting things. We are not sorting it completely, because if we sorted the whole array completely, it would actually I can say that it would waste a lot of time, and always the efficiency will be decreased. Okay, so definitely we are actually going to just check for the value, priority value. Whenever we find the priority value greater than our new NQ value, we'll simply perform shift operation. We'll simply splice that value. Okay, so let's begin with the code part. And now what we'll do is I'll just minimize it and write the code for it. Okay, so this was the code which we have written in the last videos. You can see that we have written code for circular queue, for the normal queue, and for the stack. You can see we have written code for them. So we'll be writing similar for our priority queue, similar operations. But yeah, we'll be deciding the priority by simply giving input in some order. Okay, so let's continue. All right. So let's name it as script4.js. And one more thing, if you don't know how this installation was done, if priority is less than this, yes, the exactly same thing will be performed. This dot q dot splice, yeah, we'll be actually performing the splice operation. We won't delete anything, we'll shift things with one position, and then we'll insert our lower priority value in between. Okay, things will work like that, exactly like that. Okay, so uh nice comment, by the way. All right, so let's begin. And what I'll do is right now we first of all need to create a class. Okay, then we'll create a constructor, then we'll again perform an NQ operation, DQ operation, peek perform, and then you can see is empty check, clear check, and print q check, and then size of q. Okay, fine. We'll perform all these operations, very basic operations, and just the difference will be in NQ part. Okay, NQ part will be just different. So what will actually happen is we'll just copy this and we'll just paste it. Okay, so please watch my stack and queue video so that you get an idea how I wrote this code. If you want to watch those videos, you can simply visit Geeks for Geeks practice channel. In this channel, you'll find my playlist. So in the playlist section, you'll find my playlist, data structures using JavaScript. So you can check out this playlist. All the videos are available here, and especially if I talk about stack and queues, you can see that we have a video stack and queues. So I have taught how you can write the code, what's the logic for that. Then we have also explored the circular queue, then we have also explored the priority queue, which we are doing today. Okay, so now what we'll do is we'll just name this class as priority. Okay, priority, prior. Okay, fine. So now what do we need to do is we have simply declared it as an empty items. Okay, constructor is fine. Then you can see that we have to change the NQ operation. Only NQ operation is different, not the other operations. Okay, all the other operations are fine, just the NQ operation is different. So what would we do is simply perform changes in the NQ operation. So here you can see, yeah, rest everything is fine. And one more thing, I'll just change this also, priority queue. Okay, priority queue. Okay, so now we'll continue and let's make some changes here. Okay, so what I told you is you can actually always check whenever there is an NQ, you are actually checking values based on their priority. Okay, so what two things do we need is first of all the value and then the priority value, right? We need two things. So here we'll simply say element comma priority. That's it. We needed two values. Priority. Okay. So we will simply say we'll simply say that let's first of all create a check. Okay, so I'll just say suppose the item is const item equals, and let's say that it has an object. Item is actually an object which has value of the element and the priority. Okay, so we'll be storing both of them in the array. We'll be actually creating an array. Inside that we'll be storing values in the form of object. Okay, so it's like you will say that an array is here, and objects will be created. Okay, objects will be created. It's like that, है ना? You can see that GitHub Copilot also gave me suggestions here, so you can see things will be actually stored in this format. Okay, elements value will be stored along with its priority in a single object. Okay, so this format will be actually contained in all the objects which are available in a single array. Okay, so what we'll do is let's say we want to give an input of let's make a comment, and we want to give an input of, I'll just say element is a. Okay, and then let's say its priority is 5. It's like that. Again, you will be enqueuing second element which will be having element value as b, and then it has some priority. Okay, so actually this is a good approach, but it will waste some space. So what we'll actually do is, instead of writing the priority, we'll just sort things. Okay, so suppose, what I mean is, actually suppose the priority of this one, priority of this is suppose 4. So you can see that this task, if I talk about ascending order, this task must be executed first, right? The task B must be executed first because the priority is lesser. So we'd simply sort it. Okay, we won't write element or priority, we would simply sort it. So instead of that, you can simply write a process B will be actually completed first, then A will be completed first. So instead of this, instead of writing the whole, you can simply write it in good order. Okay, it actually saves the space and it's more logical. Okay, fine. So we'll simply do this. Okay, so we are taking the values element and priority, and then we'll check previous values. We'll check the previous values. Suppose this was the case. Okay, this was the case. So what actually happened here is, now suppose new element came up here, and we'll simply say that new element is suppose B. Okay, we'll simply check B's priority is greater than priority of A or not. If it's greater than priority of A, so we'll simply write B after A. Okay, so we'll simply write B after A, value of B after A. But if B's priority is lesser than A, we'll simply write B before A. Okay, it's like that. We'll be writing B here. So it's like that. Okay, so now we'll continue, and for that we can first of all, let's say we have a flag here. Let added equals false. Okay, so for that we are actually creating a flag which will actually check have we added a value or not. If we haven't added the value, we'll simply add the value at the last. Okay, at the last. So it simply checks that if we have added the value in between, which we'll check that if priority is greater than or smaller than, something like that. Okay, we'll see. If we have added the value, we'll simply make this flag as true. But if we haven't added the value, this flag remains false. So at the end, what we'll do is we'll simply push the element at the last of the array. Okay, so what we'll do is we'll simply check that we'll have a for loop here, and let's say let I equals 0, I less than this dot q. Okay, ue dot length. Okay, this dot q dot length I plus plus. All right, so here you can see that actually this is not queue, this is items. Fine, items dot length. We are simply checking the whole items array length. Okay, whatever items are present in our array. Suppose 5 items are present, so this loop will run from 0 to 4th index, right? So now inside this, we'll simply say that if the element which I am trying to add, that element's priority is lesser than the, suppose initially you are at the 0th index, you will check that element's priority which I am trying to add is lesser than the element which is existing at the 0th index. What I simply mean is, I would say that suppose this is the case, right? This is the case. This is the case. Okay, this is the case, and I would say that items zeroth index actually contains this element. Okay, this element, it actually contains this element. Okay, right, it contains this element. So what you can actually do is, uh, guys, one more thing, this approach will fail. I thought that we can work on this, but the problem is we cannot maintain the priority values here. Okay, suppose a new element came up here, then this would fail. Okay, so you can just ignore this case. Okay, we'll go with the first case, that is we'll be storing the element and priority because it is important. Definitely it would take some extra space, but yeah, we need to keep the values, so we can't do anything. Okay, so yeah, here we have item dot priority, and I would say that the new item, okay, that is input item, is suppose this. So what must actually happen is, if I am about to create an array out of it, in both of these comparison, what element must be added first? Simply this element must be added first because it's having an priority of 3. That's what I'm saying. I'm simply saying that item dot priority, if it's lesser than this item's index, okay, that means the queue's index, so we'll simply say this dot items specific index is priority. Okay, so now it would be clear. So I'm simply checking that this item dot priority is lesser than this dot items specific index. Suppose we are at the 0th index, so we are talking about 0th index items priority, that means we are talking about this 5. I'm simply saying that if this 3 is lesser than this 5, then simply push this 3 wala item, this 3 item before, just do that. Okay, so for that we can simply perform splice operation. Okay, so this dot items, so what would actually do is it will shift this old position of a, suppose it is something like that, and suppose we have some items before this, okay, some items before this, and suppose we have some items after this, fine. So what would actually happen is, you can see that in this case, suppose if we are trying to add this in the position of this, what would actually happen is, we'll simply shift its position at one index later. Okay, then we'll simply add that value, it's like that. Okay, so we are doing the same. We'll simply check each index. Okay, wherever we find the value of our inputs priority lesser than the actual index value, okay, actual index value's priority, we'll simply shift it to the next index. Then we'll insert our input. It's like that. Okay, we'll simply say that this dot items dot splice, and inside this you can say that, just tell the index where you need to start. We don't need to delete any item, so we'll just say 0. And then what we need to paste, we'll simply say item. So what would actually happen is, you can simply paste your item in the position of 0th index. Okay, sorry, in the position of 0 index. If I equals 0, you're simply pasting it in the position of 0th index, and then we are shifting the next things. Okay, so next things are actually shifted. That means whatever was at 0th index before is now at 1 index. Now 0th index is empty, so you will add your input there. Okay, in this case. So I hope you understood this. This is a very basic knowledge, and this 0 simply means that we are not deleting anything, we are just shifting it by value, okay, by 1, and then we are inserting things. Okay, we are shifting the current index by 1. That means if index is 0, index now became 1 for the this value, okay, for this value, and now we'll simply add our input to the 0th index. Okay, it's like that. So now we have added the value, and here we can just set our flag as true. That means we have added the value, and then we can just break this for loop because we have added our value. But if we haven't added the value, what we can simply do is, we can simply push the element at the last. push the element at the last. It's like that. Okay, so we'll simply push the element at the last. All right, so it's very easy. Now dequeue operation is very same, nothing is new. You can simply dequeue by simply returning the first element. Okay, first element is returned, that means the zeroth index, whatever is it in the index, will simply be returned. Okay, that element with the less priority value, okay, the least priority value will be returned first. Okay, will be dequeued first. Okay, that means will be executed first in our case, because we are taking the ascending order. Okay, not the descending order. If descending order was there, then you would simply remove the last element from the array. Okay, it's like that. So now you can see that we have performed the peek operation, and peek operation simply gives me the item at the zeroth index. Again, you can see that we have checked is empty, same, clear the array. We can simply clear the queue like this. We can simply print the whole queue like this, and then we can simply get the size of the queue like this. Okay, fine. So we'll simply now try to add the values, but now this time the items are actually added in different order. Suppose we are giving this priority of 2, we are giving this priority of 4, and we are giving this priority of 1, we are giving this priority of 3. Okay, so let's first of all try to print this. All right, so we have some doubts here. Something for input consider new priority queue. Okay, fine. Does DSA have any use in web development? Yes, DSA has uh, a use in web development, definitely. If I give you an example, you are using Node.js backend. Okay, so Node.js actually uses JavaScript. Node.js is a framework of JavaScript. So in Node.js, suppose if a user requests something like from the backend, you are requesting data in sorted format. Okay, very basic uses. You are using data, you are requesting data from backend in sorted format. How will you get it? Okay, so there are many sorting algorithms. You must use the efficient one, or some companies create their own different kind of algorithms for different purposes. Okay, so that's how DSA can be used in the backend part, and also you can use it in the front end part. Suppose if I give you example of Amazon, in Amazon you can see that we can actually sort things. Data is still there, but we are sorting in the real time. What actually happens is things are happening in the front end also. So again, this sorting algorithms are used in the front end also, in the back end also. So it's very useful in JavaScript, or if I talk about whole development, it's very useful. Priority queue can be applied in web development task scheduling. You can use a priority queue. Okay, fine. Application task. Okay, okay. Yep. All right. So now let's try to print this. So we'll check that if there is any error. So you can see we are actually getting an object. Okay, so let's try to get the first value. Okay, we are actually trying to print this. We are actually trying to print this in a string format. So instead of this, what we'll actually do is let str equals 0. Okay, and then we'll run a for loop. Okay, we'll run a for loop, and we'll simply add things like that. Okay, add things like that, and let's try to return this string. Okay, so now if I try to run this, you can actually see now we are getting things. Okay, we can actually do one more thing. You can actually see that now the priority order has changed. Okay, in what order we have given this, so you can see 3 is at first, you can see 3 is at first, and then you can see 10 is at second, so 10 is at second, then you can see 4 is at third, 4 is at third, 20 is at fourth, so 20 is at fourth. Okay, so I have just printed them. So instead of this, I can simply say that just write this, and then you can simply say that element, okay, that specific element of the index of items will be given, and then the priority will also be given. Okay, it's like that. All right, so now we can just print this again so that we can see the change. So now you can see element is 30, it has priority 1, element is 10, it has priority 2, element is 40, it has priority 3, element is 20, it has priority 4. So you can see things are actually sorted like that. So suppose if I want to you can also check the very easy operation like is empty, size of queue, peak operation, dequeue, Now we'll be performing the DQ operation, and again we'll be printing the array. Okay, so DQ will simply remove this first element, that is 30 will be removed this time. Okay, so let's try to run this, and now you can actually see that 30 is removed, and you can see our updated arrays 10, 40, 20. Okay, again if I try to call this DQ again, what would actually happen is, if I call this, you can see now 30 is also removed, 10 is also removed, so our queue contains items 40 and 20. So things actually work like that. So this is a very basic explanation, and we have actually implemented the great approach. I could have easily sorted every time an element is added. Okay, I could have easily sorted, but instead of sorting, we actually use an approach of splice. Why use splice? Because it simply checks that current value. If this value is lesser or greater, we simply add values. Okay, we simply add values. We don't sort the complete array. So this saves a lot of time, and it's a better approach. Okay, so you can see that we have implemented this algorithm. If you still have any doubts, you can ask me any of your doubts anytime or in the live chat. All right, so I'll just wait for your doubts so that we can end this video. All right, so in the live chat or in the description, you will find a link of a course provided by Geeks for Geeks. So this is a course for DSA in JavaScript. So you can check out this course. And somebody asked right now that is DSA important in JavaScript or in web development generally? So it is very important. Why? Because I told you the example, like if you are sorting things around in front end or back end, you would always need sorting algorithms. So most efficient algorithms can be actually implemented using DSA, or you can create your own algorithms also. But yeah, DSA is helpful in that way. And the main use of DSA is actually it sharps your brain. Okay, it makes your brain think more. So it's not only about learning some algorithms, learning some concept, and it's done. It's not like that. You will be learning DSA, and you will be creating your own algorithms in future if you are in a big company. Okay, it's like that. So you can check out this course. This is a paid course, and you can check out its content if you want. In this content you will get everything from basics to advanced. All right, so this is not just for JavaScript, it's implemented to all languages. If you're later on, if you try to learn DSA in some other language like C++, all content available in this course is still applicable, just the language will be different, but yeah, concepts and logic will be same. All right, okay, so I think nobody has any doubts, so we can wrap up this video. So that's how you can actually use priority queue. That's it for stacks and queues. We covered all types of queues here. We covered stacks and queues, we covered circular queue, then we covered priority queue. I hope you understood this video. From the next video we'll be starting linked list in JavaScript. So that's it for today. I will see you in the next one. Till then, say a good day. Bye bye.